Hello everyone. So in this class I'm going to discuss progression. Okay. So start with the definition of progression and then we will see types of progression and then we will take each type of progression one by one. Okay. So start with the definition. Okay. So what is the definition? Okay. You guys know sequence, right? So some particular kind of sequences are said to be are known as progression. Some particular kind of sequences. Okay. So in a sequence, it is not necessary that terms of sequence always follow some particular pattern. And also their general term is always expressible in terms of n. Right? Right? But a sequence whose terms always follow some particular pattern and the general term is always expressible in terms of n. The general term is always expressible in terms of n. So such kind of sequences are said to be progression. Right? So we can say every progression be a sequence. But sequence need not be a progression. Every sequence need not be a progression because sequence can be based on some logical rule. Right? Okay. So just for example, if I am taking a sequence like 2, 4, 6, 8, 10 and keep going like that, and the second sequence collection of primes like first prime number, second prime number, third prime number, fourth prime number, fifth prime number and so on. So these two are our sequences, right? This is a sequence as well as this is also a sequence. But for the first sequence, I can write down the general term. The general term is twice n. Terms can be represented by this general term. Now here n is the natural number. If I am talking about sequence, then n always be from set n, natural number. Okay. Right? And also they are following some particular pattern. The difference between terms, the difference between two consecutive terms is 2. The difference between two consecutive terms is 2. So they are following some particular pattern as well. Right? And the general term is also expressible in terms of n. So it's a particular kind of sequence. So such sequence is said to be a progression. So this be a progression. While if I am talking about this sequence, so here terms are nothing but prime numbers. Right? First prime, second prime, third prime, fourth prime, fifth prime and so on. But here these terms cannot be expressible in terms of n. These terms cannot be expressible in terms of n. That is here general term not defined. We cannot define here general term for this sequence. Right? So this is not a progression. This is not going to be a progression. Just a second. This is not going to be a progression. Right? So I think the difference between progression and sequence is clear. Okay. So let me write down the definition. So a sequence, the sequence whose terms follows a particular pattern. Right? A sequence whose terms follows a particular pattern and the general term sequence general term is always expressible and the general term of sequence and the general term of the sequence is always expressible in terms of n, called a progression. Right? The sequence whose terms follows a particular pattern or follows some particular pattern, and the general term of sequence is always expressible in terms of n. Here n is nothing but point of natural number. N is in capital N sound for set of natural number, right? So this kind of sequence said to be a progression. Clear? The definition of sequence progression is clear. right? Okay, so please make a note also. Please make a note. As I said, every progression be a sequence. Every progression be a sequence, right? Some particular kind of sequences are said to be progression. Some particular kind of sequences are said to be progression. Particular kind of sequences, terms follow some particular pattern, and the general term is always expressible in terms of n, right? So that kind of particular sequences are said to be progression. So every progression be a sequence, while every sequence need not be a progression, need not be a progression, as reason as sequence can be based on a logical rule. That logical rule, I can take collection of all the primes. I can take collection of all the primes, right? Okay. Now let's take types of progressions. Okay. So mainly we have three kind of progressions. Mainly we have three kind of progression, but there are two more progressions. Okay, so let me write down them. Types of progressions. So we have mainly three kind of progressions. First is arithmetic progression. The second is geometric progression. The third one is harmonic progression, and the fourth one is, these three are our main progression. These are main progressions. Okay. We have one more, fourth one is arithmetic geometric progression. Arithmetic geometric progression, and the fifth one is miscellaneous progression. Miscellaneous progression, right? So we have these 5 kind of progression. So let's discuss them one by one. So start with the arithmetic progression. Okay, so start with the definition, right? So first I am taking arithmetic progression. Okay, so a sequence which is progression, right? Definition of progression is clear. Okay. So a progression or a sequence is said to be arithmetic progression if the difference between the term and the previous term, if the difference between a term and the previous term is always a constant, right? So let me write down it. So a progression is called arithmetic progression. In short, I'll write AP, right? So a progression is called arithmetic progression if the difference just a second, there are two definitions, so betterly okay, first I will give you two. This definition, arithmetic progression, I will define in two definitions. So first one is, so a progression is called arithmetic progression if the difference of a term and the previous term is always a constant. A progression is called arithmetic progression if the difference of a term, if the difference of a term to the previous term. If the difference, just a second बच्चा लोगों, if the difference of a term and the previous term, if the difference of a term and the previous term is always a fixed constant, if the difference of a term and the previous term is always a constant, right? And progression is called arithmetic progression if the difference of a term and the previous term is always a fixed constant. Or second, that is in general, in mathematical notation I can write like, that is, if I take n plus 1th term minus nth term, difference of this term and the previous term, the term which is previous to n plus 1th term is nothing but nth term, right? So if I take this difference, so this difference is always be a constant. This difference always be a constant for every natural number, right? And the second, we can say a progression is said to be arithmetic progression if each term of the progression can be obtained except the first term by adding a definite quantity to the previous term, right? So second definition we can say, if the terms of a sequence, if the terms of the sequence or of the progression of the sequence except first term, okay, if the terms of the sequence can be obtained, by adding a definite quantity, by adding a definite number, कुछ भी बोल सकते हैं, we can say, let's see, by adding a definite quantity, can be obtained by adding a definite quantity if, just a second bacha, if each term of the sequence, that means second term onward, if each term of the sequence except first term can be obtained by adding a definite quantity to the previous term, then such kind of sequence or progression, then such kind of sequence or progression is called an arithmetic progression, right? So we can define arithmetic progression in any of two definitions. First, the difference of the term and the previous term. The difference of a term and the previous term is always constant, always be fixed constant, or we can say each term of the sequence except first term can be obtained by adding a definite quantity to the previous term, right? To the previous term. Okay, so this definition as well as this definition is of arithmetic progression, right? See, for example, I'm taking few of sequences like 1, 3, 5, 7. It is a sequence of odd natural numbers, and like 1, 4, 7, 10, and keep going like that. So in the first, difference between 3 and 3 minus 1 is 2, 5 minus 3 is 2, 7 minus 5 is 2, right? So difference of the term and the previous term is always constant, and that constant is nothing but 2. Here that constant is nothing but 2, right? And one more thing, let me take you the previous slide. And this fixed quantity, here this definite quantity, or here this constant is known as a common difference. In these two definitions, called common difference. common difference, and this common difference is generally denoted by small d. This common difference is generally denoted by small d, right? Okay, so here this is going to be AP because here d is equal to 2. What about this? 4 minus 1 is 3, 7 minus 4 is 3, 10 minus 7 is 3. So here d is equal to 3. So these two are my APs. So we can easily check whenever a progression is given, we can easily check whether that progression is AP or not. Okay, so first of all, before let's take few example first. Okay, let me take some examples. Okay, so whenever I have some progression, so how to show whether that progression defining an arithmetic progression or not? So for that we want its nth term, that is the general term. So whenever nth term is given, then how to show a progression is an AP or not? Okay, so like let me take some example first. Like suppose I have nth term, sequence is given whose nth term is like 2n square plus 1. So I want to check whether the sequence which defining by this nth term representing an arithmetic progression or not. So nth term is given now, then how to show? So we will take this, take the n plus 1th term and nth term, and then take this difference. This difference is constant, fixed constant for every n, so then that progression will give us arithmetic progression, otherwise not. Algorithm will be algorithm of how to show arithmetic progression, right? Okay, so first find the nth term, that is an. Second, replace n by n plus 1 in an to get n plus 1th term, right? Third point, take the difference of n plus 1th term and nth term. If this difference is some constant d for all n, this difference is constant d for every n, then that will be AP. If this difference depends on n, suppose if this difference depends on n, then that progression will not be an AP. Okay, so let's do it. Okay, so here nth term is given, right? If I put n equal to 1, so this will give me what? 3. If I put here n equal to 2, so 4 9, n equal to 3 9 18 19, and keep going like that. Okay जी, so let's see AP or not. तो nth term already given है, तो n plus 1th term minus nth term, so replace n by n plus 1 to get this n plus 1th term. So 2 times n plus 1 to the whole square plus 1, right, minus nth term is like 2n square plus ka 1. Okay, just simplify it. Okay, so 2 times like n square plus twice n plus 1 and plus 1 minus of 2n square plus 1. Okay, so here 2n square to 2n square goes cancel out. I am just getting here 4n plus 2, then 3, and then minus of 1, so minus of 1, that means here just 2, right? So look at it here bachcha logo, this difference is 4n plus 2, that is difference depending on n, for the different values of n I will get different value of this difference, right? So this will imply the given progression is not AP. This progression is not AP, that is, this is not the general term of arithmetic progression. Clear? Let's take one more example. Okay, suppose I am having a is positive number, and I am taking like a and b both should be positive, because I am taking a sequence in terms of ln. A and b I am taking both positive. Okay, and I am taking this sequence ln n, ln of a square by b, and ln of a cube by b square, ln of a raised to 4 by b cube, and keep going like that. So I need to show whether this sequence defining an arithmetic progression or not. So what was our algorithm? We need to get nth term first. We have to find the nth term, right? Nth term we have to find first. Okay, so by observing the term, can I get nth term? See here, a upon a to the power 1, and then b to the power 0 will give me 1, a to the power 2, b to the power 1, a to the power 3, b to the power 2, a to the power 4, b to the power 3. So nth term is nothing but ln first term a to the power 1. So nth term a to the power n, right? B to the power 0, so that means b to the power n minus 1. This is clear to everyone? When I put n equal to 1, getting this, n equal to 2, getting this, n equal to 3, getting this, and so on. So by observing each of the term, we can easily get the nth term, right? Although there is a formula, I will give you the formula also how to get nth term of NAP. Okay, see, so now I have nth term. Now I have nth term, right? So I can easily get the n plus 1th term. So for this, replace n by n plus 1. So ln of a raised to n plus 1 upon b raised to n. Now take the difference n plus 1th term minus nth term. Okay, that is ln of a raised to n plus 1 upon b raised to n minus ln of a raised to n upon b raised to n minus 1. And with the help of property of ln, this can be written ln of a raised to n plus 1 upon b raised to n, and b raised to n minus 1 upon a raised to n. So this is nothing but ln of a upon b, right? So this difference is nothing but this, and it is independent from n. It's not depending on n, it's independent from n. Fixed constant. It's a fixed constant, right? I am getting fixed constant for every value of n. So that's why this progression is nothing but an arithmetic progression. This sequence is nothing but an arithmetic progression, right? So now you can, whenever you have a progression, you can easily check whether that progression defining an arithmetic progression or not by taking this difference. This difference should be a constant for every value of n, right? Okay then. Now let's see how to get nth term of NAP. If my progression is NAP, then how to get its nth term? So nth term, or I can say general term of an arithmetic progression. Okay, so I am supposing I am taking let a denoting first term. I am taking small a denoting first term and small d denoting common difference, right? And okay, so and my sequence is like a1, a2, a3, a4, keep going like that, an, keep going like that. This is an AP. So my question is how to get the formula for this nth term. How to get formula for this nth term, right? And this we can easily find with the help of definition of AP. What was the definition? The difference of a term and the previous term is always constant, right? And the second definition was each term except first term can be obtained by adding a definite quantity to its previous term, right? Okay, look, so here a1 is nothing but first term na, so a1 is a. So to get the a2 is nothing but the previous term which is a1, add a definite quantity, and that definite quantity is nothing but the common difference. That definite quantity is nothing but the common difference na, so add this d. Okay, to get the a3, take a2 and add this definite quantity d. To get the a4, take a3 and add this definite quantity d, and so on. Right bachcha logo? Okay, so look at it here, I can put the value of a, so this is nothing but a plus d. So my a2 is nothing but a plus d. Okay, now put the value of a2 here. A2 is this a plus d, so a plus d, that is a plus 2s d. So this a3 is nothing but a plus twice d, right? Put the value of a3. A3 is a plus 2d, that is a plus 3d, right? Similarly, a5 will be a4 plus common difference d, definite quantity, and a4 is this, so this plus so a plus 4d. So bacha logo, when I observe the pattern between a1, a2, a3, a4 and a5, then clearly I can write down the nth term. Yes or no? I can write down the nth term na, right? Okay, so here a, so put it here a. Now look, whenever I have 1, so no term with d, that is 0 into d. Here 1, 2 then 1, 3 then 2, 4 then 3, 5 then 4, means 1 less. So 1 less, that is n minus 1 into d, right? Correct. So by the observation I can easily get here nth term for the AP, where first term is a and the common difference is d. So this is how I can find nth term of AB from the beginning, right? A1, A2 up to n. So remember, this is the formula to get nth term from the beginning. Nth term from the beginning. Right? Okay. Now, how to get nth term from the end? Suppose I have arithmetic progression containing finite number of terms. So like let me write down here nth term or general term from the beginning. Okay. From the beginning. Okay, now let me take one more formula how to get nth term from the end whenever I have finite AP, and then we will take example. So second let's take here, let me call it first and then let me call it second. So nth term from the end, and it is only for finite AP, finite arithmetic progression. Okay, because whenever I have finite arithmetic progression, then only I can talk about some nth term from the end, right? Once my end is finite, then only. Okay, so nth term from the end for finite AP. So here suppose AP having m terms, m number of terms, right? And a is the first term as usual, and d is the common difference, right? Means my AP having m terms, means like a1, a2 keep going like that, an plus 1 keep going like that, am, right? And I need to get nth term from the end. I need to get formula for this. I want to find formula for this, right? Okay, so here I am just directly giving you the formula. So here nth term from the end, will be same as m minus n, plus 1th term from the beginning. Nth term from the end is same as total number of terms minus term from the end and plus 1. So m minus n plus 1th term from the beginning, right? So the formula, if you better remember this thing, right? Total number of terms should be know. So formula like a plus, instead of n I will put this m minus n plus 1 minus ka 1, and the common difference is d, so it is nothing but a plus m minus n into d, right? Okay, but there is a one more trick to get it. Do one thing. This is my AP and I need to get nth term from the end, so just revert the AP, right? That means take am minus 1, keep going like that, an, keep going like that, a to a1. Still this will be AP, and here common difference going to be negative of d, and consider this last term as first term. Consider this last term as first term, and use this previous formula. Yes or no? We can do by this. Right? So I think the second, this is going to be quite easy. Okay, although you have this formula also. So do one thing. Let's take one example based on this. Let's take one example based on it. Okay. I have to write down the example. Okay. Find the 20th term from the end in the AP. Okay. Question is, find the 20th term from the end in AP. Also find total number of terms. Also find total number of terms, and the AP is 3, 7, 11, keep going like that, and the last term is 407. Okay बच्चा लोगों, so find the 20th term from the end in the AP. This 20th term from the end I need to get, that is this term, and then 20th term from the end I need to get. Okay, so there are two methods. First one, use the formula, that is nth term from the end is same as m minus n plus 1th term from the beginning, because I know the formula for the beginning term. How to get nth term from the beginning? I have formula for this, right? So this I can easily get. Okay, but for this I want this m, and here m is nothing but total number of terms. So I have to first find the value of m, that is the total number of terms, then only I can apply this formula, right? Okay, and in the question we need to get the total number of terms. So okay, so let's find the total number of terms. Okay, so whenever I have AP, finite AP I have, and I need to get the total number of terms. So how to do this? Okay, so बच्चा लोगों, the formula is for the nth term, an is equal to a plus n minus 1 into d. Okay, so here, so just because this is the finite AP, and I need to get the total number of terms, that is 1, 2, 3 up to what is this n, right? So here last term will be considered as your nth term, because I need to get the total number of terms, means counting up to last term. I want counting up to last term, so consider nth term as the last term as the nth term. So at the place of this n, put here 407, because I need to get this n. I need to get n corresponding to this term, that will give me total number of terms. Clear to everyone, right? Okay, so whenever I need to find the total number of terms, right, in a finite AP, to always consider last term as the nth term, last term as a nth term, right? Because I need to get n corresponding to last term. I need to get the value of n corresponding to last term. That will give us total number of terms. Okay, chaliye ji. So here an will be 207 and the first term is my 3 plus n minus 1, and the common difference, I can easily get the common difference because the given series is already AP. So take 7 minus 3, which is 4. So the common difference is 4, right? AP is already given up to take difference of any two consecutive terms. Okay, so 3 plus 4n minus 4, and here 407. So this is minus 1, so 4n is equal to 408, so n is equal to 102. So here n equal to 2, that means the value of n corresponding to this last term, the value of n corresponding to this last term is 102. So that's why total number of terms is nothing but 102. This is total number of terms, right? Okay, so now we can use this formula, right? So here, okay, I need to get the 20th term from the end now. I need to get 20th term from the end. So in this formula, n is equal to 20 and m sound for the total number of terms, and here please don't get confused between this n and this n, right? Okay, m sound for the total number of terms. So here total number of terms is 102. Okay, now use this formula. Okay ji. So the 20th term from the end will be same as m minus n plus 1th term from the beginning, that is 102 minus 20 plus 1. So it is nothing but 103 minus 20, so 3, then 83, that is 83 term from the beginning, right? So I can do this here. So a is what? A is 3 plus n is 83. So 83 minus 1 into d. The difference is what? 4. So I can easily compute it. 3 plus 82 into 4, that is 3 plus, so 331. So this is my answer. So 331, this is going to be the 20th term from the end in my given finite AP, right? So this is from the formula, but as I said, this is going to be quite easy method. Okay, so let's do okay, so revert your AP, right? So consider 407 as first term and keep going like that. 11 7 3, 11 7 and 3. So here the first term going to be 407 and the common difference will become negative, that is minus of 4, because 3 minus 7 will give me minus 4 na, right? And I need to get 20th term in this series, right? Okay, 20th term, like you can write T20 or A20, right? Any notion you can use. Here I am using T4 term. Okay, anyway, because I think in the formula I was using, okay, please don't get confused. I think you guys must understand, right? Instead of this an, you can use Tn as well. T sound for the term. Okay, anyway. So T20 is nothing but A plus n minus 1 into D. So what is your A? What is your n? And what is your D? Okay, so 407 minus 19 into 4. Okay, just a second, and yes, answer going to be the same one. right? So this is how we can get some number of term from the end of a given AP. Okay, now next, okay, one more example. Let's take one more example. Okay, the question is, if pth term is, if pth term of an AP is Q, right, and qth term is P, then the question is, then find nth term, right? Find nth term, that means nth term from the beginning. If nth term would be from and, so it will be mentioned, don't worry, it will be mentioned. I need to get nth term, that means nth term from the beginning. Okay, so so I will consider A as a first term and D is the common difference. Okay, pth term, and the formula to get nth term, that is an, or same as Tn. Formula is a plus n minus 1 into D, right? Okay, so pth term, that is n equal to P. Okay, so Tp or AP. Okay, Tp is Q. This is given. Pth term of an AP is Q. Okay, so use this formula. At the place of Tp, I can put A plus n minus 1. Okay, just a second, bacha. At the place of n, I will put P na, because pth term is given. The value of n is P here. P minus 1 and the common difference is equal to 2. Okay, why I am doing this? Okay, just a second. Why I am doing this? I need to get the nth term. So nth term required A and D. To get the nth term, I want first term and I want common difference. I am considering here first term is A and common difference is D, but I need to get their value also, na? I need to get their values, right? So on the basis of given information, I will find A, that is first term, and also common difference. Once I get first term and the common difference, then with the help of this formula, I can easily get this nth term. Getting my point, huh? Right? So we want this nth term and we want this common difference. Okay, so that's why we have to use the given information. So information is pth term is Q, that is this, and qth term, that is P, right? So qth term hai, that is A plus Q minus 1 into common difference is equal to P. So these two equations I have. So by using these two equations, I can easily obtain A and D in terms of PQ. Na? Okay. So do one thing, take 1 minus 2. A to A goes cancel out. D time P minus 1 minus Q plus 1 and equal to Q minus P. Right? Minus 1 to plus 1 goes cancel out. So the value of D is Q minus P upon P minus Q, and it is nothing but minus 1. So look, the value of D is minus 1. Okay, I got D. So put the value of D in either 1 or 2. So I am putting in 1. So A minus P minus 1 into Q, right? So A is nothing but Q plus P minus 1. Okay, this is my first term. So once I get common difference and the first term, by using this formula, I can easily get nth term of the given AP. Okay, so nth term as A plus n minus 1 into common difference. So here first term A is Q plus P minus 1, plus n minus 1, and the common difference is what? Minus 1. Common difference is minus 1. Just simplify it. So Q plus P minus 1 and minus n plus 1, so plus 1 to minus 1 goes cancel out, that is q plus p minus n. So q plus p minus n, this is going to be the nth term of given AP, right? Okay, so this is how we can use a formula of finding nth term from the end as well as from the beginning, right? Okay, so let's stop today's class right now. Okay.